Hello, ladies and gentlemen. My name is Stephen Bakker. I'm from the company SAERTEX, and I am here to give a presentation on carbon UDs, carbon reinforcements for wind turbine blades. And I want to present you the difference between the solutions that are nowadays available on the market. I will talk about NCF as a fabric reinforcement compared to pultruded planks that has been coming up in the recent years as the new standard for the carbon reinforcement in wind turbine blades. Before jumping into the details on this product, I want to give you some ideas what the company SAERTEX does. Yes, we are this yellow big company in Hall 5 directly after the entrance. But what is it actually? What do we do? SAERTEX is a company, a family-owned company established in 1982. We've got a turnover of approximately 275 million euros, and we've got 1,100 very motivated employees in our team. And we produce reinforcements for the composite industry, the majority of that being non-crimp fabrics. What kind of markets do we serve? Well, we serve the wind energy. That's what I will be talking about in this speech. Next to that, we've got the automotive industry, which is, for us, definitely an upcoming market, becoming more important in the upcoming years with programs for which we are qualified today. We have the aerospace industry that is definitely a very interesting market for us. We are established there with qualifications at major OEMs for already more than a decade, and we are in serial supply. And last but not least, what we call the industry segment, marine industry for yacht building, but also different applications like for skis and snowboard and for infrastructure. Now, what kind of products do we produce? As said at the start, we produce reinforcements. Yeah, reinforcements is a very wide name of what you can do. We have glass fabrics, glass non-crimp fabrics. We've got carbon fabrics. We've got solutions that provide fire retardancy. We have additional tackifiers on our material that allow one to process the fabrics in a very straightforward way. You can put them directly in a mold and they won't slide down. On top of that, we also have a core material. It's the SAR foam that is here in the bottom right, and that is being used for decks in marine industry, but it's also something that we target nowadays for the wind industry to use in the transition section of the blade. So, talking about carbon for spar caps of the wind industry. We, as a company, have a long background in supplying carbon reinforcements for the wind industry. Now, for us, that has traditionally been non-crimp fabrics. That's our background. But at some point, the market moved towards using carbon planks, carbon pultruded planks. And SAERTEX was sitting at the sideline and watching this development. At the start, maybe we were not convinced that that is going to be the future, but we see that it's being adapted in the industry nowadays. And that is why we also decided as a company to step into this. And we set up our pultruded plank production at our headquarters nowadays. And we are starting to ramp that up. Does this mean that there is no future for carbon NCF for the wind industry anymore? Well, that's what we're going to talk about in this speech. We have some new developments, and we believe that in some applications that can also be interesting. But let's see, and I'll guide you through the presentation, and we'll show you what the relevance is of the different materials. So let me start with presenting our new Pultruded planks. We have set up a line that is using an injection technology. We're using an injection box to really inject the resin and build up a very high pressure to make sure that we have the best possible impregnation of the fibers. On top of that, we are using a special hybrid resin system, and that allows us to obtain a, a higher protrusion speed that helps us to increase our efficiency. So that is what we have done. And with that, we obtain excellent mechanical values. We reach fiber fractions more than 65%. We have the E-modulus fitting to that, directly related to the fiber fraction. But also, if you look at transverse tensile strengths, we reach values over 50 MPa, and we reach compression strengths more than 1,600 MPa. So that is confirming that our quality is really at the best possible level. So that is what I wanted to show on the carbon planks to start with. Now let's look at two new carbon NCF solutions that we have for the wind industry. So we have, first of all, our Magic Flow UD. This is the solution that we offer for very thick spar caps. You can infuse with this material up to 200 layers of a 600 GSM material. You really get this thick section of a spar cap, and you can also walk by at the boot. You can see that it really leads to a very good impregnation. And this solution is something that we can produce on a global scale. We have our production capacity available for it, and we are basically ready whenever a customer would ask us to produce. Now, how about the other solution that we have with the NCF? Well, this is a completely new technology. It's what we call Steady Plus UD. It is not only offering a good infusion, but it also includes excellent mechanical values because we reach a very high volume fraction. With this material, we reach a volume fraction of 60%. And that is important because that will allow a customer to reduce the weight in the blade. I will show you further details on that later on. And this technology also gives a very, very reliable, very repetitive structure on the material. There is no glass backing on this material. It is completely regular, and therefore one doesn't have to worry about differences in gaps in backing that can happen with other products. So how do the mechanical properties of these products look? Well, as said before, we have, especially with the Steady Plus UD, a very high volume fraction. We have 60% of volume fraction. With the Magic Flow UD, we are slightly lower, but then with that one, we can infuse more than 200 layers. And the E-modulus, yeah, you see it here, 113 gigapascal for the Magic Flow, 125 for the other one. And compression strengths, more than 0.9% as a characteristic value. So what does that mean for a blade design? I mean, that's the important part. And that is something where we as a company producing reinforcement didn't feel sure enough, experienced enough to answer that ourselves. And that is where we brought in the help of a consulting company ADC, that is doing blade design to help us answer this question. For this, ADC has looked at a blade design of a 125 meter blade, a very long blade. It's for a 12 megawatt rated power onshore turbine. You will see here some further details on the screen. And They they basically use the three different materials for the spar cap. Here you see it's numbered here with the number 1 for the suction side, opposite side on the pressure side you have also the main spar cap. That is where they used the different material solutions. And from there they analyzed what is the influence. Well, does that mean they only changed the material there? No, because dependent on the amount of material that you are using for the spar cap, you will also have to adjust the trailing edge or the leading edge spar caps. Because dependent on the weight of the turbine, the frequency also in the flapwise direction or in the longitudinal direction of the blade is changing, and that is what you have to compensate. So that is why not only the materials have been changed in the main spar cap, it had to be adjusted in the other spar caps as well to compensate for different blade weights. So here I want to show you, for completeness sake, how the materials have been used. And as said, the carbon fiber Pultruded planks, they offer the highest volume fraction. There we went into the calculation with the 65% of volume fraction. But we all know that in order to secure a good secondary impregnation of these planks, you need an intermediate layer. And that's also being included. So there was a 200 gram per square meter flow layer in between the planks to also include in the design. And therefore, the final volume fraction in the spar cap is lower than what you see as a pure material. So what has ADC been performing? They analyzed 4 static maximum load cases. And on top of that, they checked the deflection of the blade to make sure that it doesn't hit the tower. Pretty important part, obviously. And they analyzed it for all the different, for all the 3 different variants. So now let's have a look at the results. And here, put the results in terms of weight. Nowadays, the pultrusion, the pultruded planks, that is state-of-the-art, the reference. And that is indeed a very good solution for producing very long wind turbine blades. Now, if we compare that to the Magic Flow UD, the solution that gives the best possible infusion for very thick spar caps, what kind of difference do we see? Well, already in the spar cap, we see a slight increase in the weight. On top of that, to compensate this weight, also the weight in the leading edge and the trailing edge spar caps had to be somewhat adjusted. And altogether, we see that the weight increases by a little bit more than 2 metric tons. Compared to the reference with the pultrusion 70 metric tons, we talk here about an increase of about 3%. If we look towards the Steady Plus UD, we have the material with a very high volume fraction, and due to that, the difference in the weight in the blade is almost negligible. We put it here at 0.3 tons. We are talking about less than 0.5% on the blade. So that is a very interesting result. And basically, if you look at the amount of dry carbon fiber that has been used with the Pultruded planks, you need about 7.6 tons of dry carbon fiber. With the Magic Flow UD, you need a little bit more. You talk about 8 tons, and with the Steady Plus, 7.7 tons. So it is, in a way, altogether very close, and the Steady Plus UD is almost negligible in compared to the pultrusion. Now, what does this say about the cost? Because we all know wind energy is a very cost-competitive market. The levelized cost of energy has to be as low as possible nowadays in order to win the projects. And The main driver for the cost of a wind turbine blade with using carbon is the amount of dry carbon fiber that has been used. And I showed you on the previous slide that these numbers are pretty close together with a slight advantage for the protrusion. Now, one has to take into account not only the amount of material that is being used in the blade, on top of that, the amount of carbon fiber that's used for the production of the intermediate product. And that is where the NCF have an advantage. The, uh, the waste rate for producing pultruded planks is still relatively high, and that gives an advantage to the NCF. And there you see that with the Steady Plus UD, you can actually obtain a cost saving of, depending on the situation, depending on blade design, but up to 10%. So that is where actually we believe that the NCF solution can still have a future next to the pultruded planks. Now I'm coming to the conclusion, and um, the question at the start of the presentation was, well, what is the relevance of the different materials? And we talked about this a lot with our customers. We talked about it with ADC as a blade designer. And we come to the conclusion that it depends on the blade design. Do you have a blade design that is aerodynamically optimized and has some more twist or has some more pre-bend? That is very difficult to produce with a stiff pultruded plank. So that is where suddenly the NCF solution becomes very interesting, because you can drape it and get the shapes laid up. On top of that, there's the potential of having some cost saving. If you have a very straight blade on the other side, and maybe you even manage to infuse the spar cap with the protrusion directly in with the shell at the same time, that is where the pultruded plank is also an excellent solution and is probably the best way to go. So dependent on the solution, you can choose whether you're using NCF or whether you're using the pultruded solution. For us, oh yeah, before I go into the final slide, I brought also a little video for you that I would like to show. So whatever it may be, if you need pultruded planks, if you want to look for the Magic Flow UD, allowing a very thick spar cap in infusion, or whether you want to use our most innovative technology, the Steady Plus UD, we as a company are available, and I would welcome you at our booth. On top of that, we have prepared a white paper on this story, comparing all the details that we are very willing to share with you. Please ask our booth team, please ask myself, leave your business card and we can send it over. Thank you. If you have any questions, please raise your hand. And I'm available to answer also afterwards. Okay, thank you.